In this video, I will discuss the place of calculus in the landscape of the lower division math courses in a traditional community college curriculum. And by the end of this video, you should be able to understand the map of lower division math courses. And for each course, you should be able to identify the main subject or subjects of interest in the course and the main tasks that we learn, or at least supposed to learn in that course. So let's get started. And here we are in calculus. And it's not a secret that there are three courses in the calculus sequence. So we have calculus 1, we have calculus 2, and then we have calculus um, 3. However, it gets a little foggy getting to calculus, how the courses are exactly lined up and arranged in the curriculum. And this is kind of the main purpose of this discussion because those courses all together form the foundation for the prerequisite knowledge required to do well in Calculus 1 class, for example, and therefore in the entire sequence. So there's no ambiguity in how you get to calculus 2. You got to get through calculus 1, and then after calculus 2, you go to calculus uh, 3. Now, before getting to calculus, usually when I ask students what math classes have you taken so far, and I hear the words like algebra, pre-calculus, trigonometry, but what exactly is the difference between all those, or if you had to retake them again, or give advice to someone who's just about to start taking those classes? In which order do they need to be taken, if there is an order? And questions like that are usually that um, are not so easy to answer. So let's start with the list of classes. And the classes can go by different names, and especially in high school, where some of these classes can be called Math 1 or Algebra 1, 2, and 3, but within that class that is called Algebra, you actually learn a little bit of geometry, a little bit of statistics, and then a little bit of algebra. So algebra is the most popular word here, and where does it go? Again, let's just put it here on the map. And if I were to ask you where would the trigonometry be in this layout, the answer is it's definitely not sequential. Um, that is, you don't have to take trigonometry before algebra. You also don't have to take trigonometry after algebra. You can take trigonometry concurrently with algebra. So this creates two kind of parallel paths to calculus, one of which is dedicated to algebra and the other one is to trigonometry. And now, what would be the prerequisite for algebra? And it usually takes a while for students to say this word, but arithmetic is the answer. So again, I'm not saying here that there is a course called arithmetic. I'm saying there is a collection of topics that has to be mastered by each student that I refer to as arithmetic before successfully transitioning into algebra. And that's why it's a little iffy. What I call arithmetic may not be what someone else will call an arithmetic course, if there is such a thing at this point in any college. Now, before trigonometry, you probably want to be okay with geometry, so we can put this geometry at the beginning of this path and arithmetic at the beginning of this path. Now, the two courses clearly have to merge eventually, and in some curriculums, they too are independently the prerequisites for the calculus sequence. However, it is also more common than not to see a course called pre-calculus. And the main objective of pre-calculus, as you can see from this diagram, is to merge the two different paths and create some sort of unified approach to the math that you learn in both of them and get you ready to develop the next big thing, which is calculus, as the name suggests, pre-calculus. However, a lot of times we also hear the words like pre-algebra. Luckily, there are no things like pre-geometry, pre-arithmetic, but we do hear a lot of times pre-algebra. So what is pre-algebra? So let me add it here. So pre-algebra, and I do like um, separating certain objects and call them pre-algebra or pre-algebraic skills. So in this map, we will have a place for a course such as pre-algebra. So this is the rough draft of a map. Conceptually, you have to know geometry before getting to trigonometry, just like you have to know arithmetic before getting to algebra. Pre-algebra, it's a set of topics that kind of necessary to be mastered before attempting algebra. Now, together, trigonometry and algebra are either called pre-calculus or prerequisites for a course called pre-calculus, which then opens the door to this sequence calculus 1, calculus 2, calculus 3. Now, a lot of times students think that calculus 3 is the end, or you have to take calculus 3 to open the door to the next level. That's not necessarily true because calculus 2 usually is the prerequisite for many higher level math courses, which are still considered lower division, such as differential equations, and linear algebra. And sometimes there is also a course called discrete math. And sometimes you may actually start a course, proofs, mathematical proofs, logic. But the idea is that there is many more courses out there, and calculus sequence is not the end of it. But as you can see, calculus creates like this kind of a pipe, the only through which is the only entrance into this plethora of um, courses. So the purpose, the other objective of this video is to um, identify for each of these courses, and because my main goal is to discuss calculus, I'm not necessarily going to focus on what comes after the calculus, but for the sake of getting the students ready for the positive experience with calculus, I'm going to focus on what comes prior to calculus. So the main objective is to identify what, for each course, what are the main subject or subjects of interest in each course, and also identify a list of tasks learned or that you're supposed to know coming out of each of these courses. So for example, and I'm going to use a course that is completely unrelated to this calculus sequence, but some students take introductory statistics course, intro to stats. And what is the main subject of interest in introductory statistics course? I usually ask students, and after a while, everybody agree that it's data. So the main subject of interest in introductory statistics course is data. Now, what is that we learn to do with data is what we would put here in the list of tasks. And for introductory statistics course, the list of tasks is very long, so I'm not going to put anything here. It's just too much. But for each of these courses, we will identify, along with the main subject of interest, the main list of tasks that if you know how to perform, then you can probably call yourself an expert um, in that course. So the next, to fulfill that goal, I'm going to create a table like this. So we're going to have a course. And again, here by course, I don't mean the actual course that is in the curriculum, but a list of topics um, united by the common subject of interest and tasks. And for each course, we're going to list the subject of interest or subjects and main task or tasks that you were supposed to master in that course in order to consider yourself an expert um, and ready for the next course. So the first course will be, and again, this is going to be a table. So the first course is, again, if we look at this map, let's start with geometry. So if I were to ask you, what did you learn in geometry? You can pause for a second and think about it. But if you were to describe what was the main subject of interest in a geometry course, what is it? And the answer is shapes. So we learn different shapes, and that probably covers 80% of, or even more, maybe 90% of what you learn in geometry. Shapes, circles, lines, triangles, polygons, that's two-dimensional shapes. Three-dimensional shapes would be pyramids, boxes, parallelepipeds, what else is there? Spheres, and so on. What is the main task or skill that you had to pick up in geometry class? Again, I thought about it for a long time, how to summarize in one word the skill that you learned, and I couldn't think of anything better than, and usually we want to describe tasks as verbs, right? Some action verbs. Hey, I know how to, and here comes the action verb. So the action verb that comes to mind when we talk about geometry and shapes is the measure. Well, measure can be a noun or can be a verb, and here I use it as a verb. So to measure, we measure volumes, we measure areas, we measure perimeters, we measure angles, all that stuff, right? So measure is the main skill. Now, uh, let's move on to the next one. And the next one I'll make arithmetic. And as you can see, there's no way to list it sequentially, right? So at some point we have to jump from one path to another. So it doesn't matter when we do that. So let's do arithmetic. And what's the main subject of interest in arithmetic? Again, you can pause and think about it. But if you had to ask me, I would say that the main subject, in this case, subjects of interest in arithmetic, is numbers and operations. There are many different types of numbers. There are also many different operations. And and what do we learn to do in arithmetic with all these numbers and operations. And the correct action verb here will be compute. So if I ask you to compute something, regardless of the context, I could ask you to compute um, something in calculus. That task of computing something, I will refer to as arithmetic task. And there are certain things that you need to know to be able to compute things. For example, you have to know the order of operations, you have to know the properties of operations, you have to know how to perform operations and stuff like that. So I will talk more about that when I review the arithmetic. But again, if all you remember is that you learn how to compute, uh, uh, then you will sound intelligent when answering the question, what did you learn in arithmetic? Next class, let's just go here, pre-algebra. What do we learn in pre-algebra? Now, remember, pre-algebra is a bridge to algebra, so it may be easier for you to talk about algebra first. So pause the video for a second and tell me and think about it. What did you learn in algebra? And when you unpause, I'll tell you the correct answer. In my opinion, the correct answer here is that the main subject of interest in algebra is equations and inequalities. And what do we do with equations and inequalities? We solve them. And a lot of times people use the word solve wrong. Uh, they use it under some generic meaning as in English as the word solve, like, hey, solve this problem, solve this, solve that. The truth is that solve has a very specific meaning in math. And to solve means to find the solution set. That's what to solve means. But shapes don't have solution sets, numbers don't have solution sets, equations and inequalities have solution sets. So we're going to be using, or at least I am going to be using the word solve in proper context moving forward. So we solve equations and inequalities. Now, believe it or not, but the word solve is synonymous to the word graph. Because I can also ask you to graph the solution set, and that request makes sense just as much as finding the solution set. So if you know how to solve it, you know how to graph it. If you know how to graph it, you know how to solve it. So these two are equivalent tasks. And I will talk about more details and some nuances when I do the review of algebra down the road. But for right now, just if you don't believe me, then just make a note. It's the same. All right. Now, how do we go from numbers to equations? And the answer is we have to introduce variables somehow. And we introduce variables, uh, but now when you have variables, you can create things that are not covered in um, arithmetic. So what I mean by this is we have a name for 2 plus 3. 2 plus 3 is 5. So this is a number, this is a number, this is a number. However, if you write 2 plus x, we don't really have a name for it now, right? So you throw a variable into something that used to make sense, and now we have to come up with a name for it. So this is what we call expressions. That's the difference between expression and equation. expression doesn't have an equal sign, equation does. And to highlight that, we're actually going to call it not just an expression, but a variable expression. But a lot of times we omit the word variable. Now, this highlights the difference between numerical expressions, like 2 plus 3, it's a numerical expression. It has no variables. 2 plus x, now a variable expression because it has a variable. What do we do with expressions? And there are a couple things that we can do with expressions. For example, if I provide you with the value of x equals 3, then you can replace 3 for x, and then your variable expression becomes numerical expression, so we can compute it. Now, this process of evaluating, of replacing a variable with a value and computing it is called evaluating the expression. So we can evaluate variable expressions. However, sometimes what we like to do is, before we evaluate an expression, we may want to do this thing called simplifying an expression. So before you evaluate this expression, for example, you may want to notice that 3x minus 2x is just plus x. So instead of plugging in x equals 3 here and here, we can simplify it and then evaluate it. So the main two tasks that you have to be able to perform with variable expressions are to evaluate and to simplify. So if I ever ask you to simplify something, like, for example, I can ask you to simplify the right side of the equation. That's what I would refer to as a pre-algebraic task. Now, you may not realize this, but expressions are building blocks of pre-calculus. It is fair to say that, because everything you know up to calculus is kind of relies on your ability to break down an equation into left-hand side, right-hand side. But when you remove the equal sign, these are just expressions. And further down the road, when you look at the function, your function is defined by using an expression. And if your expression has only one variable, it's a function of one variable. If your expression has two variables, then it's a function of two variables. But again, most importantly, if you don't have this basic skill, that is, if you cannot simplify an equation, an expression, then down the road that may result in your inability to simplify an equation. And that may result in your also inability to simplify a function to make it look simpler and therefore to make it easier to work with. So again, that's why I call expressions are the building blocks of algebra and pre-calculus, because if you don't know how to work with them, then you kind of shooting yourself in the foot here, because everything is made of expressions. All right, now let's move on. After algebra, we have, again, it's not after, it's parallel development, but let's talk about trigonometry. What do we learn in trigonometry? In trigonometry, it's actually interesting because we start trigonometry with taking a deeper look into triangles. But what comes out of it is very surprising, because we end up with developing new operations, trigonometric operations, which allow us to create trigonometric expressions, which result in trigonometric equations, in our ability to create and comprehend trigonometric equations. And then we haven't mentioned it yet, but also functions. It's something that we're going to be studying down the road. So in trigonometry, we also learn about trigonometric functions. So while initially the subject of interest was just triangles, the type of tasks that we have to learn how to perform in this class, it's extensive list. But again, I'm just going to write here solve and graph, because we solve triangles, we solve trigonometric equations, we graph trigonometric equations, we graph trigonometric functions. But then there's also one other skill that we learned in this class, that students tend to not remember thoroughly, but identities, right? What do we do with identities? Well, you have to know identities, but the main skill here, I guess, is to prove identities. So I'll just make a whole new line here, and I will write proof identities. Now, identities are not exclusive to trigonometry. We learned identities in algebra too. Here's an example of one algebraic identity. So what is an identity? It's just a statement that is true for all values. And if you don't like identities, you're not going to like trigonometry. But every single identity that we learn in trigonometry is used and definitely can be used in multiple ways in calculus class. So this is really, really important. All right, now let's talk about pre-calculus. So remember, the purpose of pre-calculus is to unify the approach to things that we learn in trigonometry and algebra and get you ready for calculus. So if I were to answer this question, what is the main subject of interest in pre-calculus, I would say functions. So everything now becomes a function. Absolute value used to be an operation, now it's a function. Sine of x used to be a operation, now it's a function. Everything is a function now, and we learn to think of everything as functions. And the main thing that we do with functions is graphing is number one skill, but there are also other skills, such as for every function, and there's no easy way of saying it, I guess. For every function, you have to be able to describe it using this whole new language that we pick up along the way. So not only you should be able to graph it, but you should also know how to identify its properties. And by that, what do I mean? You should be able to answer questions like, what is the domain of this function? What is the range of this function? What is the equation? And can it be written in a different form? Where is the function increasing? Where is the function decreasing? Where is the concavity? Like just by looking at the function, does it have a maximum? Does it have a minimum? Is it symmetric? Does it have asymptotes? Things like that, right? So I'm just gonna identify the properties, but this list of properties is extensive, and I will go in more detail over this in my review of pre-calculus later on. Now that we are done with all the prerequisites, what is the main objective of calculus? And I guess I can even start a whole new page for this. What is the main objective subject of interest in calculus? Well, we kind of continue digging into functions. So we're still interested in functions, but at a different level. So the main tasks that we learn to perform in calculus are, and again, this is something that you may not know because you just entering calculus, but again, after exiting the calculus 1 and 2 sequence, if someone asks you, hey, what did you learn in this class? Well, you should say, I learned how to find limits. So functions have limits. We're going to learn about that in calculus class. I learned how to differentiate, and differentiate, again, it's a proper way of saying I know how to find derivatives, and I know how to integrate. So for any function, these are the things that you should be able to do with it after finishing the calculus class. Find the limit, find the derivative, whatever that means right now, and integrate or find an integral. Now, I'm not going to dive too deep into this, but you should also know the main subject of interest in linear algebra, for example, what to look forward to when you take in linear algebra class and differential equations, for example. Now, I'm not going to tell you the tasks because I don't want to spoil the experience for you, but the main interest in linear algebra, I guess it's much easier to start with differential equations because the name tells you everything. The main subject of interest in differential equations is differential equations. So it's kind of the next approach, the next level of equations. So if these are differential equations, what are these equations? You can refer to these equations as numerical equations because the unknown is a number. Here, the unknown is a function, and instead of looking for an unknown quantity, we're now looking for an unknown function. So um, it's interesting course. In linear algebra, again, if you were to describe in one word what is the subject of interest, you should say matrices. Matrices, it's the plural of matrix, and that's also the next level of of study related to equations. So it starts with it's kind of like trigonometry. You start looking at triangles, and then you're like, oh, wait a second, there is more to it. And here's the same thing. You start looking at matrices, you learn what to do with matrices. Then you start looking at solving systems of equations, and then turns out that those two can be merged together, and that's what linear algebra does. But again, in one word, what's the main subject of interest? You should say matrices. Now, I forgot to say this here because I just used the word systems, but then I forgot to mention that here. Subject of interest, equations and inequalities. So, and we have to continue here. And systems of equations and inequalities, right? So this is why algebra takes a long time to present. And if it was too easy, then we wouldn't have to take a whole 16-week courses to learn algebra. Or in high school, there's like years of learning algebra. So this is, again, the map of the lower division math courses. As you can tell, there's like this pipeline, pre-calculus, calculus, calculus, that you have to fit in first and then come out, and you have to know what it takes to get in here, and you have to know what is out there once you get out. And that being said, I'm going to wrap up this video, and once again welcome you to calculus sequence, calculus course. And next, in the future videos, I will go over the prerequisites to calculus, such as arithmetic, algebra, trigonometry, and pre-calculus. So if you have any questions, feel free to reach out.